Video lesson 2.2 for our forensic science unit is on electron configurations. My objectives for you tonight with the lesson tomorrow is that you'll be able to write out electron configurations for elements through argon. You'll be able to explain the process of organizing the electrons for a given atom also. Up until now, you've been taught how to do an atomic structure, where you drew out the picture. You placed all the protons and neutrons inside the nucleus. Then the electrons were arranged into electron shells around the nucleus of the atom, with 2 electrons in the first shell, 8 electrons in the second shell, and then 8 electrons in the third shell. But how do we take care of the electrons for elements with more than 18 of them? With tonight's lesson about electron configurations, what we are doing here is we are defining how the electrons are placed around the nucleus of the atom in a way that's going to allow us to place electrons for elements with 118 electrons. And so electrons are arranged into energy levels, sublevels, and orbitals. Energy levels are similar to what you know as electron shells from before. The higher the energy level, the further you are from the nucleus of the atom. So if I were to draw a picture here in the corner, and this is our nucleus, okay. As we move out from the nucleus of the atom, our energy level is going to increase. So here we have 1, 2, 3, and you can have up to 7. So here's 4. Within the given energy level, there's further division, and these are referred to as sublevels. And each sublevel can hold a specific number of electrons each. So an s suborbital can hold a maximum of 2 electrons. A p suborbital can hold a maximum of 6 electrons. A d suborbital can hold a maximum of 10 electrons. And then an f sublevel can hold a maximum of 14 electrons. Each sublevel is further divided into orbitals. And an orbital can hold a maximum of 2 electrons. So if we were to look at an s sublevel, it has 1 orbital. Okay. A p sublevel has 3 orbitals. A d sublevel has 5 orbitals. And an f sublevel has 7 orbitals. What does this all mean when we put it together? And I want you to fill this out in your note guide to start out with. If we were to put together now the energy levels, the sublevels, and the orbitals, we can start writing an electron configuration. To begin with, my first energy level only has an s sublevel and 2 electrons. My second energy level has an s sublevel with 2 electrons, but it also has a p sublevel with 6 electrons. The third energy level has an s sublevel with 2 electrons. It has a p sublevel with 6 electrons. And then it also has a d sublevel with 10 electrons. My fourth energy level has an s sublevel. It has a p sublevel. It has a d sublevel. And it also has an f sublevel with 14 electrons there. We can continue this. We can continue this here with the fifth sublevel, which is going to be 5s2, 5p6, 5d10, and 5f14. Okay? There's also a 6th energy level and a 7th energy level. How do you go about writing an electron configuration? Because you don't want to have to write out the entire thing every single time. And on an exam, this is one of those things that I said before that you could copy onto the back of your periodic table. So on Friday in class, I'm going to give you some time to copy this onto your periodic table. If we go ahead and look at hydrogen. Hydrogen has only one electron. Hydrogen's electron configuration is simply going to be a 1s1. And the reason I write just 1s1 instead of 1s2 is there's only one electron to place. If we continue with helium, which has 2 electrons, we get 1s2. Let's look at lithium. Now lithium from before has 3 electrons. My first energy level can only hold a maximum of 2, so I place it just like I would for an electron shell in an atomic structure model. My third electron then, I go to the second energy level and I place 1 electron. If we look at beryllium, which has 4 electrons, becomes 1s2, 2s2. Boron at 5 electrons becomes 1s2, 2s2, 2p1. To further clarify how to write an electron configuration, I'm going to give you 3 rules that you should complete on your note guide there. The first is the off-bow principle, and this says that electrons have to fill the orbitals with the lowest energy first, then move to a higher energy orbital. This is exactly what you were taught when you had to complete the electron shells for an atomic structure. We always started out with electron shell number 1 and moved out to electron shell 2 and then electron shell 3. So we are going to start always with energy level 1. So start with energy level 1. And we are going to always start with our sub-level S, and then however many electrons that we have to put in there. That's how it will always start. The Pauli exclusion principle looks at the orbitals within a sublevel. And if you think about this, electrons have a negative charge to them. Okay? And when you put 2 negative things together, they're going to repel each other. So electrons are going to try and spread out as far away from each other as they can to minimize the amount of that repulsion. So if we were to draw our 1s2 electron configuration, and we were to draw it as orbitals instead, okay? An s suborbital or an s sublevel only has 1 orbital that has 2 electrons, and so to have the greatest distance, one of those electrons is going to spin clockwise and one of them is going to spin counterclockwise. And this way they can be as far apart from each other as possible. If you were to look at a sublevel that had, we were to look at a p sublevel, that had 6 electrons, each orbital again can only hold 2 electrons, so I would need to have 3. And they are going to, again, fill so that one spins clockwise and one spins counterclockwise. The last rule is referred to as Hund's rule. And what this says is within a given sublevel, you want to spread those electrons out as much as possible. So if we take, for example, here a p sublevel again, which has 6 electrons, okay? And it's 6 electrons at the max. If I only have a p sublevel that has 3, I'm not going to write it so I have 2 electrons in one sublevel, or one orbital, one electron in another orbital, and then none in the last one. This way is wrong. Instead, I'm going to spread it out. And so 1 electron would go into each of those orbitals.